आपण मानक समस्त को आरकेबी ब्लॉग्स रे स्वागत। ठीक अच्छे आउ ठंडा मत प्रबल है तथापि माने बसवा भी अनकम्फर्टेबल लगुच। ठीक अच्छे माने एमती लगुच शरीर में किसी बल ना। ठीक अच्छे से भाया फिलिंग हो ठंडा प्रबल नाकर पानी पूरा बाहर सिकाड़ी बाहर देखिए आज आम पढ़ा जा डिजोल्यूशन माइंड मेकअप कर डिजोल्यूशन पढ़ी ना प्री फॉर्मुलेशन स्टडी पढ़ी। ठीक अच्छे मुझे आज भावुँ डिजोल्यूशनटा पढ़े मो बेटर तापर प्री फॉर्मुलेशन स्टडी मैंने पढ़ी देखा जाऊ। ये डिजोल्यूशनटा आमर गोटे अच्छी बही गोटे अच्छी आम बी फार्मार गोटे बही पढ़ू। ठीक अच्छे इंडस्ट्रियल फार्मासी। ठीक अच्छे इंडस्ट्रियल फार्मासी गोटे बही अच्छे देखुच केड़े बड़ बही मोटा बही बसिक गोटे ये देख ब्लैकमैन आ लिबरमैन का द थियोरी एंड प्रैक्टिस ऑफ इंडस्ट्रियल मेडिसिन 4th एडिशन। एडिटर कौन है रूप केकर SP व्यास फरहान जे अहमद गौरव के जैन। ठीक है ये सब हूँ एडिटर। ठीक अच्छे आउ ये 4th एडिशन CBS पब्लिशर एंड डिस्ट्रीब्यूटर आपको बनई मैंने प्रिंट कर मोटा बह। ठीक अच्छे आम आज पढ़ा डिजोल्यूशन। ठीक अच्छे बहुत सारा चैप्टर मैंने बहुत चैप्टर अच्छी मैंने जो देखा जी कौन कौन अच्छी खाली गोटे मैंने ब्रीफ इंट्रोडक्शन दे। ठीक अच्छे मिक्सिंग अच्छी ड्रिलिंग अच्छी इवापोरेशन अच्छी डिस्टिलेशन अच्छी ड्राइंग अच्छी क्लारिफिकेशन एंड फिल्ट्रेशन अच्छी फार्मास्यूटिकल रियोलॉजी अच्छी फार्मास्यूटिकल यूटिलिटी अच्छी डिजोल्यूशन अच्छी ये सबू जिते माने चैप्टर ये आसूँ सेक्शन आई रे प्रिंसिपल ऑफ फार्मास्यूटिकल प्रोसेसिंग मैंने तापर गोटे सेक्शन 2 आमर अच्छी। ठीक अच्छे से अच्छी सेक्शन 2टा हूँ फार्मास्यूटिकल डोसेज फॉर्म डिजाइनिंग। ठीक है एते आसूँ प्री फॉर्मुलेशन आसूँ बायो फार्मास्यूटिक्स आसूँ एंड फार्माकोकाइनेटिक आसूँ तापर तुम आसूँ फार्मास्यूटिकल स्टैटिस्टिक्स एंड ऑप्टिमाइजेशन आउ गोटे सेक्शन 3 अच्छी से कौन अच्छी ना सेक्शन 3टा को आमर कहुच्छी फार्मास्यूटिकल डोसेज फॉर्म। ठीक अच्छे तो फार्मास्यूटिकल एक्सिपिएंट एंड पॉलीमर ता अंडर आसूँ टैबलेट आसूँ कैप्सूल आसूँ माइक्रो एनकैप्सुलेशन आसूँ सस्टेन्ड रिलीज ओरल डोसेज फॉर्म आसूँ मोनोफेजिक लिक्विड बाइफेजिक लिक्विड सेमी सॉलिड सपोजिटरी फार्मास्यूटिकल एरोजल स्टेरिलाइजेशन स्टेराइल प्रोडक्ट नोवेल ड्रग डिलीवरी सिस्टम टारगेटेड ड्रग डिलीवरी सिस्टम तापर आमर गोटे सेक्शन IV है सेक्शन IV आमर कौन कौन आप्टर पायलट प्लांट स्केल अप एंड प्रोडक्शन मैनेजमेंट तापर पैकेजिंग मटेरियल साइंस तापर आसूँ काइनेटिक प्रिंसिपल एंड स्टेबिलिटी टेस्टिंग तापर क्वालिटी मैनेजमेंट क्वालिटी कंट्रोल एंड एश्योरेंस तापर ड्रग रेगुलेटरी अफेयर। ठीक अच्छे तापर अपेंडिक्स रे तुम वेब एड्रेस एंड पोर्टल सब रोची सॉल्वेंट मिसिबिलिटी टेबल रोची लिमिट ऑफ रेजिडुअल सॉल्वेंट रोची प्रिपरेशन ऑफ स्टैंडर्ड बफर सॉल्यूशन। तो आज आम जोटा पढ़ा आज आम पढ़ा कोटा उपरे आज आम पढ़ा सेक्शन आई सबुठ जो लास्ट चैप्टर। ठीक अच्छे लास्ट चैप्टर जोटा अच्छे मैंने डिजोल्यूशनटा आम पढ़ा। ठीक अच्छे डिजोल्यूशनटा आम पढ़ा देखिए डिजोल्यूशन टिके डिजोल्यूशन पढ़ा इच्छा हो तो डिजोल्यूशनटा टे देखिए 182 पृष्ठ अच्छे डिजोल्यूशन। आउ मते मोर जो पढ़ा स्टाइल टी अच्छी मो पढ़ा स्टाइलटा जनरली केमती मुझे भी पढ़ी मोर सदा बेले गोटे रफ नोट थी माने मोर गोटे सेंटेंस लिखार अच्छी मत गोटे सेंटेंस को पूरा रफ नोट्रे लिखी बहुत लोग अच्छा मेंटाल मैंने पढ़ी दिखती मैंने मन मन भितर पढ़ी दिखती मो पढ़िया स्टाइल सेमती हुए मो पढ़िया स्टाइल हूँ मुझे पूरा चिल्ले चिल्ले पढ़ेगी कारण यदि को पार्टी करके न पढ़े मैंने मत निद लगे मत गोटे गाउंदिया भाया गोटे मैंने गोटे लगे तो मोर पार्टी करके पढ़े हाल्ला मैंने बहुत थर मुझे चेष्टा करी मन भितर सब जिन पढ़ापी मन भितर सब जिन करने कि मो द्वारा से संभव हुए सेमती पढ़ी पारे बहुत रेयर पढ़े बट मोर से गोटे स्टडी पैटर्न ही ना तो मत सदा माने गोटे चिल्ले चिल्ले पढ़िया मोर गोटे भारी आनंद थाए बहुत अल्प पढ़े कि जी पढ़े मुझे साटिस्फाए अनुसार पढ़े आउे मो पढ़ा शैली केमती माने मु फास्ट जो पढ़े फास्ट आग 2-3 थर माने पढ़ी दिए कौन अर्थ मत बुझार ना कौन अर्थ मत जानार ना बास मुझे मो इच्छा अनुसार एमती माने नुहे 3 थर माने यहाँ रेकर्डिंग हो कारण आज यही समस्याटा मो सहित बहुत है माने मुझे कौन कहूँ माने जे पर्यंत मो पढ़िया स्टाइलटा केमती ना जदि मुझे न पढ़े मत भारी प्रोब्लेम आसो मैंने कौ जिन गोटे मन लगे जदि धन्य मन मन लिखी कि मन मन ये पढ़ी मैंने मनरे सब जिन चलो ताहले मैंने बहुत प्रोब्लेम हुए मुझे किसी जानी भी पारे ठीक अच्छे तेणु देखिए आज रिजोल्यूशन में जेनराली आम 182 पृष्ठ स्टार्ट हो सरुचि जेनराली केते पृष्ठ सरुचि आपणकर 213 पृष्ठ तो जदि रफली आम एस्टिमेशन करवा तो 3 होगा 80 20 200 तो 30 पेज पाखापाखि ठीक अच्छे एमतिया 30 पेज पाखापाखि 30 पेज माने आई थिंक 15 आस कारण 2% कैलकुलेट कर 15 पेजेस टोटाल बोधे आस देखिए रिजोल्यूशन कौन अच्छे resolution. How resolution is a physico-chemical process by which a solid substance enters the solvent phase to yield a solution. Resolution is a physico-chemical resolution एक physico-chemical प्रोसेस है ठीक है बाय व्हिच जो कि कौन हुए ए सॉलिड सब्सटेंस का कौन हम ना एंटर करिवो द सॉल्वेंट फेज एंटर्स द सॉल्वेंट फेज ठीक है गोटे सॉलिड सब्सटेंस कौन कर सॉल्वेंट फेज रे एंटर कर टू याइल्ड ए सॉल्यूशन टू याइल्ड आमको दब कौन ए सॉल्यूशन रिजोल्यूशन साधारण काम होची सी आमको गोटे सॉल्यूशन करके दब आ रिजोल्यूशनटा होची गोटे फिजिको केमिकल प्रोसेस प्रथम कथा रिजोल्यूशनटा होची हमर गोटे प्रोसेस को प्रकार प्रोसेस ना फिजिको केमिकल प्रोसेस रिजोल्यूशनटा होची गोटे फिजिको केमिकल प्रोसेस जो कौन हुए गोटे सॉलिड सब्सटेंस रे एंटर करिवो सॉल्वेंट फेज तो सॉल्वेंट फेज को जदि एंटर करिवो ताने सॉलिड सब्सटेंसटा हम पई कोन हेजिवो सॉल्यूट हेजिवो Dissolution release. Dissolution मतलब release of a drug from the dosage form. Dissolution माने होची release of a drug from the dosage form is a prerequisite for any orally administered drug to be systematically effective. Dissolution is a key prerequisite for any oral administered drug to be systematically effective. In case of a oral drug product, the release properties are mainly influenced by disintegration of the solid dosage form into granules, de-aggregation of a granule to yield fine particle, and dissolution of a drug from the fine particle into solution. Both dissolution and disintegration are parameters of prime importance in the product development strategy, with disintegration usually reflecting the effect of formulation and manufacturing process variables, and the dissolution reflecting not only the effect of processing and formulation but also influence the solubility and particle size, which are largely properties of the drug raw material. From the dosage form perspectives, dissolution of active pharmaceutical ingredient rather than disintegration of the dosage form is often the rate determining step in presenting the drug in solution to the absorbing membrane. Prior to the emergency of dissolution test are being official in the pharmacopoeia. Disintegration test were the only official in vitro test used by major pharmacopoeia throughout the world as means of in vivo release predictability and product performance. Like disintegration testing, dissolution tests do not prove conclusively that the dosage form will release the drug in vivo in a specific manner, but dissolution does come one step closer in that it helps establish whether the drug can become available for absorption in terms of being in solution at the site of absorption. Initially, dissolution tests were introduced to characterize the release profile of a low solubility. Low solubility मतलब less than 1% drug in aqueous media. But now the emphasis is to adopt a dissolution test in monograph of all oral solid dosage form with minor exception. Example है non-absorbed drug. Not surprisingly, any report in literature on formulation and development of any solid dosage form start with dissolution testing. The importance of dissolution testing increased steadily, and of the 674 monographs for oral tablet and capsule listed under USP 28, 582 include the dissolution testing. USP 28 also include dissolution test for suppositories, granule and suspension, and a drug release test for 47 modified release tablet and capsule and 2 transdermal delivery system. With evolution and advancement in dissolution testing technology and the understanding of scientific principle and mechanism of test result, a clear trend has emerged wherein Resolution testing has moved from a traditional quality control test to a more valuable tool to guide formulation development, assess product quality, monitoring the manufacturing process, and in some cases predict in vivo performance of a solid oral dosage form, and as a surrogate measure for bioequivalence, and to provide biowaivers. Dissolution profile comparison has additionally been used extensively in assessing product sameness, product sameness, especially when post-approval changes are made. This chapter focuses first on the mathematical concept of the dissolution along with the influence of physicochemical properties on the dissolution of the drug, and then describe all the compendial dissolution apparatus, their modification, and their use for dissolution testing of many types of conventional and novel dosage forms. The last section of the chapter provides some basic emphasis on the role of dissolution testing in the granulation of a pharmaceutical. Now, dissolution mechanism. Drug dissolution is a multi-step process involving heterogeneous reaction at solid-liquid phase boundaries. The heterogeneous reaction that constitute the overall mass transfer process are considered to take place in two steps. पहला, connective transport of the soluble solid through the hydrodynamic boundary layer surrounding solid liquid interface to the bulk phase. That means diffusion limited model. ଆଉ ତାପରେ ସେକେଣ୍ଡ ଟା ହେଇଗଲା a reaction at the solid liquid interface, the so-called interfacial transport, reaction limited model. The slower of these steps exercise a dominating influence upon the rate of dissolution. In dissolution, the interfacial transport is virtually instantaneous, and so the rate of dissolution will more frequently be determined by the rate of slower step of diffusion of a dissolved solid through the hydrodynamic boundary layer. The flow close to the solid surface can be separated into two main regions. Within the bulk flow region, viscosity is negligible, whereas near the surface, a small region exists that is called the hydrodynamic boundary layer. In this region, adherence of a molecule of the liquid to the surface of the solid body slow them down. The hydrodynamic boundary layer is dominated by pronounced velocity gradient within the fluid that are continuous and does not, as in sometime purported, consist of a stagnant layer. According to the Newton's law of friction, pronounced velocity gradient leads to high friction forces near the surface of a solid particle. The hydrodynamic boundary layer grows further downstream of the surface since more and more fluid molecules are slowed down. The hydrodynamic boundary layer governs the overall mass transfer. Now तापर आसुची डिफ्यूजन लिमिटेड मॉडल, और इसे बोला जाता है फिल्म थ्योरी. The rate of diffusion is described by Fick's law. Rate of diffusion is described by Fick's law of diffusion expressed as dc by dt इज इक्वल टू के चेंज इन सी मतलब के डेल्टा सी वेयर के इज ए रेट कांस्टेंट यूनिट है सेकेंड इनवर्स एंड सी इज ए कंसंट्रेशन ऑफ अ सॉलिड इन सॉल्यूशन सी होची कंसंट्रेशन ऑफ अ सॉलिड इन सॉल्यूशन at any point and at time t. The first dissolution experiment were conducted by Noyes and Whitney 1897 and found that the dissolution rate जिसको बोला जाता है dc by dt is a linear function of the difference between the bulk concentration that is called to Cb at time t and the saturation solubility that is called to Cs. bulk concentration मतलब Cb, saturation solubility मतलब Cs. This statement can be formulated mathematically as follows. So dc by dt, so dcb by dt is equal to kd Cs minus Cb. kd क्योंकि यहाँ पर सिंपली के था तो यहाँ पर हमको ये करना पड़ा dc by dt, सो kd हो गया ओके Cs minus Cb, C is saturation solubility minus bulk concentration. ओके सो चेंज इन C का जो वैल्यू है वो Cs minus Cb हो गया. नाउ K कैसे KD हो गया मुझे ये पता नहीं. ओके वो मेंशन कर रहा है वेयर KD इज द डिसोल्यूशन रेट कांस्टेंट. सो यहाँ पर आपका KD डिसोल्यूशन रेट कांस्टेंट. ठीक है तो हम समझने में कोई दिक्कत नहीं. लैटरल नॉर्स्ट एंड बर्नर 1904 showed that KD is a composite constant being proportional to the diffusion coefficient D and the surface area of the dissolving body S. Thus equation 2 was modified to what is known as Nernst and Brunner equation. Brunner equation, Brunner equation, B-R-U-N-N-E-R, Brunner equation. Now, so dc by dt हम क्या लिख सकते हैं? dc by dt को हम लिख सकते हैं ds Cs minus Cb divided by Vh. So where H designates the thickness of a hydrodynamic boundary layer and V is the volume of the dissolution medium. Where H in 1931 Dixon and Crowell makes the equation 2 applicable to dissolving compact object by expressing the surface S of equation 3 with respect to the weight that is called W. By this consideration, equation 2 when integrated yields Dixon, Crowell or cube root law which relates time to the cubic root of weight. Now W0 to the power 1 by 3 minus W to the power 1 by 3 is equal to कितना हो जाएगा K2T, where W0 is the initial weight and K2 is a constant. ना कुछ मैथमेटिकल एक्सप्रेशन मुझे समझ में नहीं आया, पहली बार पढ़ रहा हूँ. ठीक है क्या करूँगा, बहुत गर्मी हो रहा है. जरूरत से ज़्यादा हो रहा है. टाइम पड़ुଛି हे प्रभु ଥଣ୍ଡା ଆସିଲା According to the equation of noise and quickly and Norst and Brunner, the dissolution rate depends on a small fluid layer called as hydrodynamic boundary layer adhering close to the surface of a solid particle that is to be dissolved. The above approaches can be categorized as various expressions of the diffusion layer model as a physical explanation for dissolution process, where the limiting step has been considered to the diffusion of a molecule through a stagnant film of liquid around the solid surface. The diffusion limited model has been exclusively based on experiment in rotating and stationary disk apparatus or flow through cell under well-defined hydrodynamic conditions. Departure from the diffusion layer model have been reported in powder dissolution experiment in the USB paddle apparatus and in gastrointestinal absorption studies. In this case, the dissolution rate does not seem to be proportional to the difference between the concentration of the dissolved drug and the saturation solubility as suggested by the diffusion layer model. Now, reaction limited model क्या होता है? Dissolution mechanism based on interfacial transport is so-called reaction limited model. The difference between the reaction limited model and the diffusion layer model is that while in latter the solubility is a thermodynamic parameter and drives the dissolution rate. In the former, solubility CS is the result of a chemical equilibrium. In a reaction limited model, dissolution is considered to be a reaction between the undissolved species and dissolution medium molecule. The rate of dissolution is therefore driven by the concentration of the undissolved species, and solubility is considered to be the concentration when the reaction equilibrium is reached. The model exhibits rich behavior mimicking the profile obtained by the classic equation, but also shows additional flexibility which may prove useful in dissolution curve fitting. The assumption utilized by the model may be particularly applicable to in vitro conditions, potentially explaining the observed variability and deviation from the diffusion layer model principle. The approach could also be applicable for surfactant facilitated dissolution of the drug, interfacial barrier, and Dan-Watt model, which describe the heterogeneous feature of the drug dissolution, are the two approaches which can be considered as a reaction limited dissolution model, since both do not rely on the premises of the dissolution principle, of the diffusion principle. Sorry for that. बहुत गर्मी हो रहा है. interfacial barrier model, limited summation theory. The interfacial barrier model, limited summation theory, proposed by Wilderman 1909, considered that the interfacial transport rather than diffusion through the theory is the limiting step due to a high activation energy level for the former. According to this model, an intermediate concentration can exist at the interface as a result of a summation mechanism and is a function of solubility rather than diffusion. This model has not been studied in detail and an explicit mathematical description for the dissolution kinetics is not available. However, the rate of drug dissolution G, that is controlled by the interfacial reaction, was reluctantly expressed as G is equal to K into Cs minus Cv, where K is the effective interfacial transport constant. उसके बाद Danckwatt model. The next model for reaction limited dissolution is Danckwatt model, which appeared in 1951. According to this model, constantly renewed microscopic packets of solvent, मतलब eddies, reach the solid surface and absorb the molecule of solid, delivering them to the bulk solution. The concept of a Danckwatt model for drug dissolution is shown in figure 8.1. Okay, and is expressed by the equation dC by dt is equal to A into Cs minus Cv square root of gamma d by d, where gamma is the rate of a surface renewal. Now factor affecting dissolution. Once the dosage form reaches the absorption site, it must disintegrate, deaggregate and release its therapeutic agent. Figure 8.2 indicates solubility problem that may be encountered after the administration of a drug in an oral dosage form. The lack of ability of a drug to go into solution is sometimes a more important limitation to its overall rate of absorption than its ability to permeate the intestinal mucosa. For many drugs that cross the intestinal mucosa easily, the onset of a drug level will be dictated by the time required for the dosage form to release its content and for the drug to dissolve. The dissolution process is primarily dependent on pharmaceutical variable with a possible exception of a pH dependency, a patient-related variable. The relative importance of the various processes illustrated in figure 8.2 may be explained in terms of a Nernst and a Brunner equation, whereby dissolution is described by a diffusion limited model. So dC by dt is equal to ds into Cs minus Cv divided by dH. There are many physicochemical and physiological factors which can have a great influence on the factor in equation number 3 and therefore on the dissolution rate. Now drug associated factor क्या होता है? Factor influencing the effective surface area of the drug particle, that is called to S. So particle size. An important factor determining the dissolution rate is the particle size of the drug. The dissolution rate is directly proportional to the effective surface area of the drug, which may be increased by physically reducing the particle size. Faster initial dissolution rate obtained by grinding or milling the drug can often can often be attributed to both an increase in the surface area as well as changes in the surface morphology that lead to a higher surface free energy. However, an increase in edges, corner defect, and irregularities on the surface of a porous grade drug particle can also influence the effective hydrodynamic boundary layer and hence the dissolution rate. Micronization to particle size of about 375 micrometer is often a successful strategy for enhancing the dissolution rate of a poorly water-soluble drug, and exemplified for glycophenolate and toluene chemical. It has been shown that microcrystalline form of nitrofurantoin, जो कि less than 10 micrometer, is more rapidly and completely absorbed as compared to macrocrystalline form, that is called the 74 centimeter 177 micrometer. The effective surface area also depends upon the ability of the dissolution medium to wet the particle surface. When the dissolution medium has poor wetting properties or when the drug is hydrophobic, aspirin, phenobarbital, and phenacetin, micronization might result in a decrease in dissolution rate. It is probable that decreasing the particle size of a hydrophobic drug actually decreases its effective surface area due to agglomeration. In fact, smaller particles of a hydrophobic drug have more air absorbed on their surface, resulting in floating of a drug on the dissolution medium. Now wetting. A rough estimate of the wettability of a hydrophobic drug by a given medium can be obtained from the contact angle at the liquid or solid interface and the structure of the drug. A compound not very well wetted by water possesses a large contact angle. It is worth noting that the media such as SGA, SIA, and water used during in vitro dissolution testing do not contain surfactant and therefore fails to address the possibility of wetting and the associated enhancement of dissolution rate. The bile salt in the small intestine plays a very important role in decreasing the contact angle of a poorly soluble drug. Addition of the bile salt to the medium containing a drug with large contact angle results in enormous increase in the dissolution rate. However, bile salt have little influence on the dissolution rate of the drug with a small contact angle. Deaggregation. The rate of disintegration of the dosage form and the size of the resulting aggregates can be a rate limiting factor step in the dissolution process. As illustrated in figure 8.2, after a dosage form disintegrates into larger particles, these larger particles must deaggregate to yield the fine particle. Hence, deaggregation is often a prerequisite for dissolution. The formulation that degrades rapidly results in larger surface area forms has particles of exposed to dissolution medium. Aggregation decreases the effective surface area, limit the exposure of a drug to the dissolution medium, and thus decreases the dissolution rate. Now, manufacturing process. Various manufacturing process can affect dissolution by altering the effective surface area of the drug particle either by addition of a hydrophilic diluent or surface acting agent. Granulation. In terms of achieving higher resolution rate, wet granulation is considered superior to dry granulation and direct compression procedure. Wet granulation impacts hydrophilic properties to the surface of the granule and thus improves the resolution rate of poorly soluble drug. Additionally, the use of hydrophilic fillers and dyes such as starch, lactose, microcrystalline cellulose tends to improve the resolution of the active ingredient. Now compression process. Bhagavan. Jai Shri Ram. Compression forces. The high compression force result in an increase in the interparticle bonding density and hardness, decreases in solvent permeability and inhibition of wettability of the tablet due to the formation of a firmer and more effective sealing layer by the lubricant under the high pressure and temperature generated during compression. All these effects due to high compression forces decreases the resolution rate. Formulation ingredient. It has been shown that resolution rate of a pure drug can be altered significantly when mixed with various excipients that are added to satisfy certain pharmaceutical functions such as dilute, जिसको हम बोलते हैं फिलर, dyes, binder, granulating agent, disintegrant and lubricants. Generally, identical tablet and capsule product manufactured by different pharmaceutical manufacturers are found to exhibit significant difference in resolution rate of their active ingredient. Several studies have shown that poor tablet and capsule formulation cause a marked decrease in bioavailability and impairment of the clinical responses. Such findings, especially for life-saving drugs like digoxin and tolbutamide tablet, as well as for chloramphenicol and tetracycline, were the triggering factor that compelled the drug regulatory and the compendial agency to institute the dissolution test as a legal requirement for most solid dosage form. Now granulating agent and binder. Tablet granulated with gelatin solution provide a faster resolution rate in gastric fluid than those prepared using sodium carboxymethyl cellulose or polyethylene glycol PEG 6000 as a binder. This observation is attributed to the fact that gelatin imparts a hydrophilic characteristic to the hydrophobic drug surface and decreases contact, whereas sodium carboxymethyl cellulose is converted to its next soluble acid form at a low pH of the gastric fluid, and PEG 6000 forms a poor soluble complex. Even gelatin obtained from various processes and from different origin has shown to affect the resolution rate of the dosage form. Now disintegrating agent. The type and amount of a disintegrating agent employed in the formulation significantly control the overall resolution profile of the dosage form. Increasing the starch content from 2% to 5% result in a threefold increase in the resolution rate. The effect of a starch depends on its swelling characteristic when it comes in contact with water, which results in better and quick disintegration. Another disintegrant, primose, is found to be ineffective, particularly if added after granulation. Now, lubricating agent. Lubricating agents are often added so that the powder mass does not stick to the processing machinery. The nature, quality, and quantity of a lubricant added can affect the dissolution rate. The effect of a lubricant on the dissolution rate of a salicylic acid tablet has been studied, and it has been concluded that magnesium stearate, a hydrophobic lubricant, tends to retard the dissolution rate, whereas sodium lauryl sulfate enhances it due to the hydrophobic character and surface activity of the latter, which increases the wetting and a better solvent penetration into the tablet. Effect of a lubricant on the dissolution rate of the drug from the dosage form would also depend on the properties of the granule, the lubricant itself, and the amount of a lubricant used. If granules are fast disintegrating and hydrophilic, a water-soluble surface-acting lubricant will have an insignificant effect on the dissolution. Most lubricants such as magnesium stearate, aluminum stearate, stearic acid, talc are hydrophobic. They decrease the effective drug solvent interfacial area by changing the surface characteristic of the tablet, which results in a reduction of its wettability, prolongation of its disintegration time, and decrease the rate of dissolution. Now, factor influencing saturation solubility of a drug, that is called CS. Okay. The saturation solubility is a key factor in the Nernst and Brunner equation, as together with the concentration of a drug already dissolved and the thickness of a hydrodynamic boundary layer. It determines the concentration gradient across the boundary layer, which is the driving force for dissolution. Although the saturation solubility, that is called CS, influences the apparent dissolution rate constant, it is an intrinsic property of a drug compound and can therefore affect the hydrodynamic boundary layer indirectly. High aqueous solubility, for example, leads to concentration-driven convection at the surface of a drug particle. Various physicochemical and physiological factors influence the saturation solubility of a drug in the gastrointestinal tract. These include its crystalline form, lipophilicity, and ability of a drug to be solubilized by native surfactant and co-ingested foodstuff. Its aqueous solubility and pK and the gastrointestinal pH profile. Then polymorphism. Now, polymorphism. Many drugs are able to crystallize in several forms, each having a different energy and thereby differing physico-chemical properties such as melting point, solubility, heat of a fusion, density, उसके बाद refractive index etc. Depending on the relative stability, one of the polymorphic form will be more stable than the other. Stable polymorph represent the lowest energy state, highest melting point, and the least aqueous solubility of the drug. Other forms termed as metastable form represent high energy state, low melting point, and a higher aqueous solubility. Polymorphic form has been shown to influence the solubility and therefore the dissolution rate of numerous drugs including chloramphenicol, novobiocin, and chlorpropamine. The polymorphic form III of a riboflavin is 20 times more soluble than formamide. The bioavailability of a drug may also be increased by selection of an appropriate polymorph, but for the reason other than increase in drug solubility. In the case of a chloramphenicol palmitate, the rate of enzymatic hydrolysis differs among polymorphs since only the free base form of the chloramphenicol is efficiently absorbed. The conversion rate of the ester to the free base will be controlling factor in the overall rate of absorption. Enhanced dissolution rate through appropriate polymorph selection does not, however, always leads to improved bioavailability, as can be seen for metastable form of a diflunisal. Commercial exploitation of a metastable form with higher solubility is limited by the possibility of a interconversion of polymorphs both during manufacture and subsequently during storage of the dosage form. Amorphous form of the drug having no internal crystal structure represent the highest energy state and have solubility higher than their crystalline counterparts. Among pseudopolymorphs, organic solvents have higher aqueous solubilities than anhydrous form of the drug, whereas hydrates have lower aqueous solubility than anhydrous form. Whereas hydrates have lower aqueous solubility, hydrate का lower aqueous solubility रहेगा anhydrous form का. हे भगवान मुझे तो आज खाली आज वीडियो रिजोल्यूशन केते ना पढ़े दी तीन थर रिडिंग मारिबा कंप्लीट चैप्टर को कारण मो पढ़ार स्ट्राटेजी होची मो हठात कौ जिस को जानिले हठात ताको बुझे चेष्टा कर मोर पढ़ा स्टाइलटा होची माने बिल्कुल फास्ट सेमिति माने नुहे मु अति कम रे कोनोसी चैप्टर को या फिर से चैप्टर रे जते कंटेंट अछि मने कर गोटे पैराग्राफ अछि मु कम से कम ताको तीन थर पढ़े आउ से तीन थर रे मु किछि बुझिबा को चेष्टा करेनी खाली जस्ट एक ओवरऑल रीडिंग मार दिए तापरे जिमती आपण सुनिथिबे एनसीईआरटी लाइन बाय लाइन सुनजन ना मो पढ़ा स्टाइल सिमती तापर जो पढ़ी मु जो जो जिनस को बुझी पाइली कारण एटा बहुत सारे मैथमेटिकल इक्वेशन अच्छी या मु बुझी पाइली तो एटा केमिति डिराइव होची गुडे गुडे जिनस को बुझी पाइली किंतु फुल्ली साटिस्फाई मु हेइनी ठीक अछि तो मु कोन करे ना सेटा को तीन थर पढ़ी सारला परे मु देखिबी आगो को वर्ड सब मते कष्ट कष्ट लागुची को वर्ड माने एमिति भी वर्ड अछि जोरा कि माने समस्त जानि जंदी किंतु मु जानिनी माने एमिति भी अछि माने बहुत छोट छोट वर्ड ताकू भी मु जानिनी तो से सब जिंस को मु कोन करे मु खातारे पूरा लिखे पूरा माने नेट रु खंगाली करी कि डिक्शनरी देखि करी ता मीनिंग सब बाहर करी ठीक है एआई रो पूरा भरपूर यूज करी आ आजिका डेट रे मु आपन को सजेशन दउची एआई जदी यूज करना हती आपण एकाथरे माने इंग्रेज अमल रे पहुंची जिवे कारण एमिति एआई हाँ एआई गोटे एआई रे गोटे विचित्र जिनस मु देखिची जे एआई बेले बेले हमको रॉन्ग इनफॉरमेशन देता है मु एटा ही माने किंतु सेटा आपण जो आपण गोटे सब्जेक्ट पढुछंती ठीक अछि आपण गोटे चैप्टर पढुछंती आपण गोटे पैराग्राफ पढुछंती तो आपण सदा बेले रिलेट करंतु जेता बेले एआई को को जिंस पचारिबे जे मु एई वर्ड रो मीनिंग जानि पारनी कि मैथमेटिकल एक्सप्रेशन ये कैसे आया उसका स्टेप बाय स्टेप कैलकुलेशन मुझे बताओ ठीक है तो आपण सदा बेले कोन करिए बुक सहित से वर्ड को मिलेबे जोटा एआई रु आसीथिबो तो सेटा जदि मैच खाइला तो जानिबे जे कोन एई वर्डटा रो मीनिंग होचे एया ठीक अछि ना तो मु कोन करे इमती वर्ड सबु माने जो वर्ड मते कष्ट लागे एया नुहे जे आउ जनक पई मु के पढेनी मो निज पई पढे सब एटा समस्त जानि समस्त निज पई पढନ୍ତି ठीक अछि तो से कष्ट कष्ट वर्ड को पूरा लाइन बाय लाइन एनसीईआरटी के फॉर्म में पूरा एक सेंटेंस में लिखूंगा उस एक सेंटेंस में कितने वर्ड मेरे को नहीं आ रहे उसका मीनिंग लिखूंगा फिर उस सेंटेंस का जो ओवरऑल मीनिंग है वो मतलब लिखूंगा एंड एक प्रिपरेशन जब ये खत्म हो जाता है उस सेंटेंस को पढ़ते हुए कितना कॉम्पिटिटिव में क्वेश्चन आ सकता है ये मेरा प्रिपरेशन करने का तरीका मेरा पढ़ने का तरीका सिंपल है इस तरह से मैं पढ़ता हूँ ठीक है जरूरी नहीं 3 बार मिनिमम मैंने बोला 3 बार मैं इसीलिए पढ़ता हूँ क्योंकि चीजें दिमाग में सेट हो जाते हैं कई बार 3 बार पढ़ने से भी नहीं होता है तो मैं क्या करता हूँ ज्यादा बार भी पढ़ लेता हूँ इस तरह से ठीक है एंड जो चीज मैं पढ़ूंगा हो सकता है मैं उसे एक्यूरेटली बता नहीं पाऊं लेकिन उसका मीनिंग सेम टू सेम रहे ठीक है मीनिंग हमारा पढ़ने का उद्देश्य क्या है कोई भी चीज आप पढ़ रहे हो उसका मीनिंग क्या है इतना हमें पता होना चाहिए ज्यादा कुछ नहीं बस सो ऐसे स्टडी विथ मी ब्लॉग बहुत बार आएगा लेकिन आज मुझे थोड़ा सर्दी जुकाम हुआ है बहुत ठंडा हुआ है नाजल कंजेशन फील कर रहा हूँ उस कारण से आज के ब्लॉग को यहीं पर हम रखते हैं किसी और एक ब्लॉग में मिलते हैं टिल देन बाय थैंक यू जय हिंद वंदे मातरम थैंक्स फॉर वाचिंग भारत माता की